Welcome to our 9-2 video. Our lesson essential question is, can I determine area of a sector and segments of a circle? Now to go into some definitions, the area of, what is this? The area of a sector, or what a sector starts at the center and it goes out on the radius, and the area would be this part and this part. And the area or a segment is when I take a chord and I'd have a chord as an line segment. It has endpoints on the edges of the circle, and the area would be all of this. So it does not include the area of the sector triangle part. So that's a little foreshadowing of what the area would, how to find the area. The equation for area of a sector is going to be represented by the variable a, and it's going to be central angle, which is represented as m, over 360 times the area of a circle, and the area of a circle is pi r squared. So this is the very important equation you'll want to know. If you recall from our last lesson on 9.1, this equation is very similar to the equation of an arc length. So the only difference is that I'm finding area, not arc length. M over 360 is the same. That's just the fraction of the circle that the arc length or the circle represents. And then it's the equation for either area of the circle or circumference of the circle. So how do I find the area of a segment then? Well, I'm going to find the area of the sector, which is the whole thing, and then subtract this triangle bit. So let's get going. Area of a segment, area of the sector is this first part. So I'm going to look at this. That's a 90-degree angle. So I have 90 over 360 equals, times pi times radius, and radius is 8 square root of 2 minus 1/2 times base is 8 square root 2, and height is 8 square root 2. This base and height, those are all radiuses, or radii, as probably would be the correct way. So I'm going to say 8 square root 2 times 8 square root 2. Now I got to get this into a simpler form. So I can see that 90 over 360 would be the same as 1/4. Oh, I forgot. This is squared. Then I can write pi. 8 squared is 64. And the square root of 2 squared is 2. Subtracting 1/2 times 8 is 64. And the 2 times, square root of 2 times 2 is 2 is 2. Further simplifying, I can cancel these 2's out, and I'm left with just a minus 64. I can cancel out the 2 and the 4, and I'm left with a 1/2 times 64 times pi. These can cancel out, so I can get 32 pi, and this is going to be my answer, but it's area, so remember it's centimeters squared. So you guys try this one. Realize the video didn't pause all the way, but you guys probably could figure it out. So I'm going to take my equation, 90 over 360 times pi r squared, I forgot the squared there, minus 1/2 times 10 times 10. So this is going to be 1/4 again, times pi times 100 minus 100 divided by 2. So I can basically simplify this to become 25 pi minus 50 centimeters squared. So that's going to be my answer. This one's a little different because the central angle is not 90, it is 60. But not so hard. So I'm going to take 60 over 360 times pi times r, which is 4 squared, minus 1/2 base times height. Now, here's the problem. If this is my base, my height is going to be this measurement, not this measurement. It worked well for base times height on this one because this was base and this was height. So how do I find the area of this triangle? Well, I maybe remember from last chapter, it's 1/2 times A times B times the sine of C. So this comes back, I'm going to use this trig equation. I'm going to have 1/2 times A and B, so that's 4 times 4 times the sine of 60. Pause the video while I solved. I did 60 over 360, 4 squared is 16. All this combines to 8.377. The sine of 60 is roughly 0.866 times the 16 over 2 gives me 6.928. Put this in the calculator and I get 1.45 inches squared. Okay, so I want you guys to try this one. Hey, welcome back. This one may have thrown you for a loop, but I think you guys can figure it out. First, if I recall from previous two slides, this is the same measurement of 10 and the central angle of 90. So I could have just taken 25 pi minus 50. I did the math here, 90 over 360 times pi r squared minus the area of the triangle equals 25 pi over 50. But that's going to be the area for this. I don't want the area for that. I want the area for everything but that. So I'm going to take the area of the entire circle, which is pi r squared, minus the area of this segment, and then I get 285.619 inches squared. Okay, I have a more traditional one for you guys to try. You guys have a dog. There's a 10-foot leash that's attached to the corner of this doghouse. It can run out 10 feet, so the rope goes, and the house is 10 feet. He has 10-foot radius all the way here. So how big would this angle be? And then figure out what my area of this sector, if the circle part would be. But then don't forget, this is 8 long. So it's going to have another 2 feet of area on the back side of the house. So that's going to be 2 and 2 and 90. So you're going to do this equation 2 times. One to get the big number with 10, one to get the smaller number with 2. Okay, so I'm going to have the area of the first sector being 270 over 360 times pi times 10 squared plus 90 over 360 times pi times 2 squared. This number equals roughly 235. This number equals pi, or 3.14. Add them together, and I get 238.76 feet squared. So, to recap, our lesson essential question, can I determine the area of the sectors and segments of a circle?